Today, I'm going to show you how to run an ANCOVA test in the SPSS system. Our research question is there a significant difference in the scores of students taught by Smith, Jones, and Brown when considering the number of periods missed? The null hypothesis would be that there is no significant difference in the test scores. And then the alternative would be there is a significant difference in the test scores. Now, before we run the ANCOVA, we have to check for a couple of assumptions. So with our data, the first thing that we need to do is we need to go to Analyze, Descriptive Statistics, and then Explore. Now we're going to move our dependent variable over, which is our test scores, and then our factor list would be the class. Then what we need to do is we need to go to plots, uncheck stem and leaf, make sure you check histogram and the normality plots with test, and hit continue. Hit OK. And here we have our N values of 30 for Smith, 30 for Jones, and 30 for Brown. We're going to scroll on down and we're going to look at Levene's test of normality, and we're going to check the Shapiro-Wilks. And here are the classes, Smith, Jones, Brown, and the significance is 0.927 for Smith, 0.899 for Jones, and 0.548 for Brown. Since all of those are greater than the 0.05, then this does pass the test of normality for this data. Also, we can check the histograms for each class, and this is Smith's class here, and it has a beautiful normal bell curve here. Here is Jones's class. It has a relatively normal bell curve, and so does Brown's class, has a relatively normal bell curve. So another thing that we want to check for the ANCOVA is to make sure that there's a linear relationship between the variables and the covariate. So in order to do that, you go up to Graphs, and we're going to click on Scatter Dot, Simple Scatter, and Define. I'm going to move my class on the x-axis, the test scores on the y-axis, and the periods missed on the set markers by, and hit OK. Now we can look and see at that graph, and there is a linear relationship between class 1, class 2, and class 3. So statistically, we want to check those numbers as well, just to make sure. And in order to do that, so we're going to check the homogeneity of regression slopes, and we go up to Analyze, General Linear Model, Univariate. And we're going to move our dependent variable, which is our test score, over, our fixed factor over, and then our periods missed under covariate. And then what we're going to do is we're going to click on model, and we're going to build custom terms. So I'm going to do all three. So I'm going to move the class down and click add. I'm going to move periods missed down and click add. And then we need both of them together. So we're going to do class by periods missed, move it down, and click add. So now we have that one as well, and we're going to hit continue. And we're going to hit OK. Now we can see from our test of between subject effects here, we have this row right here, the class by periods missed, and we're looking at that significance level, and that's a 0.488, which is greater than 0.05. So this data does pass the homogeneity of regression slopes. So now that we know that we can assume the data, we can go ahead and perform the ANCOVA. So what I'm going to do is I'm going to go up to Analyze. I'm going to do General Linear Model, Univariate. And there I have my dependent variable test, my fixed factor class, my covariate periods missed. I'm going to make sure that all of my options are where they need to be. So I'm going to click on Model. Make sure we're going to do full factorial. And then we need to click EM means. We're going to move class over for display means for, and we want to compare main effects. We're also going to move this confidence interval adjustment down to the Bonferroni and hit continue. Then under options, we're going to do the homogeneity test. We can do the estimates of effect size and hit continue on that one as well. Then we're going to hit OK. So here we have our three classes. Smith is 1, Jones is 2, Brown's is 3. Our Levene's test, our significance is 0.691. So again, this data passes for the Levene's test. And we're going to look at the test. Oh, I'm going the wrong way. We're going to look at test of between subject effects. And here we have all of the data here where I'm just looking at the periods missed, the class here. So we're going to look at class because that was what was affected in our data from the periods missed. So we have our degrees of freedom 2. We have our F value of 4.116. And then our significance is 0.02. Since that is less than 0.05, then we can reject the null hypothesis and say that there is a significant difference between the test scores versus the periods missed when adding the periods missed in as the covariate. Now that partial eta squared, that effect size is a 0.087, which is slightly larger than a medium effect. So I would say that this is a medium to large effect size for the data. We're going to scroll on down and we're going to look at the estimated marginal means here. We have the adjusted means. So we have Smith at 84.097, Jones at 79.931, Brown at 80.472. So you can see here that there might not be a huge difference here, but from Smith and Jones, it looks like there is a huge jump there. So let's statistically look at that. We're going to look at the pairwise comparisons. And we're going to look at the significant difference between the classes. So between Smith and Jones, the significance is 0.029. Since that is less than 0.05, there is a significant difference between Smith and Jones. Now we're going to look between Smith and Brown, and that is a 0.075. So since that is greater than 0.05, then there is not a significant difference between Smith and Brown. Last but not least, we're going to look between Jones and Brown. We've already looked at Jones and Smith, so we're going to look at Jones and Brown, and that's significant is greater than 0.05, so there is not a significant difference between those test scores. So we can conclude that, yes, there is a significant difference in the overall class test scores, and that significant difference falls between Smith and Jones with a significance of 0.029. That effect size, again, was 0.087, which is a medium to large significant difference.